Good day, everyone. Thank you, Lance, for that introduction. My name is Ian Gittens. I'm a director in the Deloitte Omnia AI Factory, and with me is Ashkan Rahimian, and we're here to present the Cyber AI product suite and specifically attack path modeling. Next slide, please. So artificial intelligence is no longer on the horizon, it's here, and it's already having a profound impact on how we live, work, and do business. AI can and will transform organizational decision-making, drive efficiencies, and build capabilities and businesses, and power sustainable, value-driven activities. To achieve this, we have developed a practice within Omnia called the Omnia AI Factory. This is where strategy meets intelligent design. We coordinate and synthesize the powers of Omnia AI to create unique and targeted products that optimize the way a business works. Next slide, please. So within the product suite that we have a significant product suite called the Cyber AI product suite. And that is comprised of 4 significant products that we are developed, one of which is attack path modeling. Attack path modeling is an AI-enabled solution that provides a graphical visualization of your network, showing quantifiable risk exposures via attack paths designed to complement your crown jewel protection strategy. Cyber AI is a more reactive tool that is taking a look at EUBA capabilities to identify and prioritize risks derived from user and entity behavior. Phishing analytics sounds like what it sounds like. Essentially, it is a way of identifying phishing attacks and enables organizations to amalgamate their security operations, teams, and more effectively. And identity access management is an AI-enabled role maintenance and risk monitoring tool to address entitlements and actual role creation within an environment. Next slide, please. To drill down a little bit more detail associated to attack path modeling, I'm going to pass the mic to Ashkan, who is the grandfather of this tool and the origin.
Thanks, Ian. Hi, everyone. So the product that we'll be showing you today is called APM, which stands for Attack Path Modeling. As Ian mentioned, APM is part of the Cyber AI suite of cybersecurity and artificial intelligence products that we're developing here at Omnia AI Factory. APM is an AI-enabled solution that's using graph analytics in order to do predictive analysis and attack surface analysis on cybersecurity data. One of the differentiators of APM is that it is essentially a proactive threat identification platform as opposed to the majority of security controls that are detective in nature. And the graph-based technology allows APM to implement knowledge inference. And some of the techniques from machine learning and analytics are used as part of APM in order to provide recommendations automatically based on some of the security issues or vulnerability exposures within enterprise environments. There are 2 versions of APM. There's the APM IT, which applies to information technology environments. Most clients and enterprises would use the IT version. We also provide an OT or operational technology version of APM, which can be used for crown jewel protection or digital and physical crown jewel protection across IT and OT environments. In terms of APM features, it can help predict vulnerable entry points, can compute attack paths and calculate risk scores, or essentially quantify the risk around crown jewels and digital assets. And it can also use its AI engine to come up with recommendations or provide optimized remediation strategies for vulnerability management teams and security operations, SOC systems. I'm just gonna switch the screen to show you a live version of the application. So this is essentially the IT version. Let me just zoom in a little bit. So APM's graph is the heart of the platform. Let me just start with the dashboard first. So as I mentioned, there are two versions of APM, APM IT and APM OT. Both versions provide visibility into the current risk score or an aggregated enterprise level risk score across line of businesses and operational groups. Here's an example of the dashboard, what we refer to as the CISO dashboard, or the security information for trends over time, the crown jewels that are currently exposed, the assets that are currently exposed, line of businesses, and digital crown jewel profiles. And what do we mean by profile? Essentially a group of applications or servers that form a technology stack. And as you can see here, this is an example of a crown jewel profile for an online banking platform. So we have various levels, layers related to the front end web applications, the back end databases, and platform can help us identify vulnerabilities at each layer. It also provides access to asset properties, device information, and also allows analysts to look at the indicators, IOCs detected through EDR systems or through the SIM, as well as the feasible attack patterns according to MITRE's platform, TIDs, that could be used from a pen testing perspective to get to the crown jewels. So we also have access to a set of recommendations. Similarly, on the OT version, we have two types of essentially tiles on the dashboard. Tiles that are related to physical crown jewels, like SCADA devices or PLC controllers, and information around IT assets. The list of top recommendations, list of essentially pending items, and number of assets that are being monitored are also available on a dashboard. So when it comes to attack path modeling, one of the challenges security teams are facing these days is to get visibility into exposure vectors. So this is what we refer to as a reachability graph. And on the reachability graph, all the nodes here indicate VLANs or subnets. Within a VLAN, we might have one or more assets. And the gray lines on the graph represent reachability routes. These are routes that are allowed through ACL rules or firewall devices or network appliances. And we ingest those rules directly from firewall configuration managers or firewall controls. The red lines on the graph represent attack paths. So if you're familiar with the concept of a vulnerability chain, essentially APM can compute the pre and post conditions of vulnerability chains automatically and visualize the routes and traversals on the graph. So these are examples of lateral movement path on the graph. Each asset will be highlighted using an icon and a node on the graph. The number represents a risk score, and crown jewels are visualized using a halo and a little diamond icon on the graph as well. So here's an example of an attack path that APM has computed for us. So between the source being workstation 2 and the target being server 19, APM has identified this specific route as the polar, what we refer to as the path of least resistance. And it factors in all asset properties, security controls, the vulnerabilities that are discovered on the assets. It also looks at the essentially indicators or IOCs discovered through an EDR or through network controls. And the inference engine has identified certain attack patterns or techniques that may be feasible against those crown jewels as well. So on the right-hand side, we have access to a list of attack paths, starting from the source all the way to the target. These are all the assets that are part of that attack path. If you click on a node, it'll walk us through the potential attack cycle. And we'll also have the option to interact with the graph and define source and target nodes by right-clicking on a node in order to implement the strategy for attack path modeling. So to give an example, if I wanted to set the server 6 as the source of an attack potential scenario, and workstation 2 as the target, or vice versa, we could interact with these nodes and essentially let the system compute the potential attack path between them on the fly. As you can see, some of these nodes are connected, and this essentially means that there are reachability rules in place, allowing those nodes to be accessible and reachable from source and target. So right now, this is what we computed on the fly. And as you can see, there are multiple ways to either directly or indirectly move from source nodes to target nodes. And when it comes to vulnerability analysis and essentially prioritization, sometimes security operation teams may decide to prioritize patching based on CVIDs or CVSS score. But in some scenarios, looking at the context of assets would make sense. So essentially, you might have devices or assets that are connected to crown jewels but are not considered to be crown jewels themselves, and prioritize patching of those assets as opposed to the crown jewel itself. And in some scenarios, that would be the best strategy because it'll break the essentially the attack path or the chain more efficiently than patching the crown jewel directly. Now, we talked about the attack path modeling based on vulnerability data. When it comes to OT environments, typically speaking, you have two separate environments. You might have boundaries between the IT and OT networks. And in some scenarios, firewall rules or security controls that may be in place will not allow communication between these boundaries. So APM OT can automatically identify scenarios in which the firewall, because of potential firewall misconfigurations or changes in dynamic changes within the environment, such vectors become available and become essentially facilitate attack routes between the two isolated or segregated zones. So here's an example of an attack originating from the IT side and targeting an asset, is actually a physical asset on the OT side. And APM, using the graph analysis, can help us identify such scenarios and recommend preventative measures to essentially eliminate these attack paths or to reduce the risk score related to physical and software assets. Now, in addition to vulnerability-based attack paths, we also have the option to do attack path modeling based on access-based attack paths. So typically speaking, because of potential misconfiguration on Active Directory or LDAP or other IAM platforms, certain users may be able to access crown jewels using credentials that are extracted from the systems, or essentially extracted from memory of systems running those authorized applications. Here's an example. So from workstation 2 to workstation to server 19, we are doing attack path analysis on essentially the same scenario. There are two ways to get to the crown jewel or get to the target. One is to go through the vulnerability exploitation and lateral movement across multiple subnets. And the other one is to essentially look into the memory of workstation 2 and see who are the users that have active sessions on that machine, and using some techniques, or some attack techniques, there are ways to extract those credentials out of the memory of workstation 2. And in this case, we're using a user who happens to be a member of the server admins group, and that group is the admin to server 44, who and server 44 as an entitlement is a member of the Exchange Trusted subsystem, and that specific group owns server 19. So through the inheritance of privileges, and this is essentially an application of Bloodhound platform, we are able to visualize the misconfiguration ADs or scenarios such as unconstrained delegation that could facilitate access-based attack path. And APM can help identify and ingest the data and visualize it on the graph as well. Now, one of the other powerful features of APM, which is again based on graph technologies, is the ability to simulate attack path as well as recommendations applied to mitigate those attack paths. So when we identify a list of attack paths, so these are essentially high-risk routes that attackers might leverage in order to laterally move across the network or gain access to crown jewels. Now, the AI engine learns these patterns, and it has knowledge of the techniques according to the MITRE attack matrix and according to a set of threat intelligence sources, and is able to map these attack paths to a set of vulnerability remediation items, as well as some security recommendations. to enhance the overall baseline or the overall security posture of the platform. So certain recommendations are related to patching. So if you know what CVIDs are there and which ones are like what vulnerabilities are currently known and published, we will be able to essentially generate recommendations of type patch or patching. And then some other recommendations are related to security control configuration changes. They're more about updating rules or updating policies on the platform. And there are recommendations that are more strategic in terms of adding or removing certain security controls to a zone. I'm connecting through a VPN, might be a little bit slow here, but on the right-hand side, here's an example of the list of recommendations that are generated based on the current discovered attack path on the graph. So if I expand this list, APM can visualize the current state of the network as well as the potential changes after applying those recommendations to the graph. So here we have the current risk score quantified to 96. And as I go through the list and accept some of these recommendations, as you can see, the risk score, the predictive or future state risk score, as well as the attack path risk score levels will decrease as well. So these are generated by APM automatically and prioritized based on the number of attack paths that will be eliminated as a result of applying those changes. And some of these are of type patching, some are related to configuration, some are related to threat models and security control changes. And the end result of all those changes would be a lower risk score from a future or predictive state perspective, as well as the changes to criticality levels of those attack paths as well. So here, example, we have 10 critical level attack paths as indicated by the color. And after applying these recommendations, we'll be able to reduce or eliminate certain attack paths from the environment and reduce it to 10 medium level or criticality level attack paths. So we won't be able to eliminate them completely, but we'll be able to make it harder from an attacker perspective to actually exploit those paths or to move across the network by removing certain vulnerabilities from the path. And as a result of that, the total number of crown jewels impacted in the future score will be reduced from 4 to 2 in this example. And so through the graph simulation function, we can actually see the impact of removing or applying these recommendations to the graph before applying any changes across the network. So essentially the VM teams or security operations teams can leverage the simulation function and come up with the best course of action or to identify the most impactful recommendations automatically. And as a result of that, generating a plan for the VM team to go ahead and apply those patches in a certain order. So the other aspect of the platform is the ability to generate tickets with or generate essentially what we refer to as remediation packages. So to give you an example, if I go ahead and select some of these items and essentially add them to a remediation package, the platform will create a ticket for us based on all these changes, and there's the option to get an approximate level of impact and effort applied to each of these items as well. And then we are able to submit that to a source system, a security orchestration platform, and then keep track of the changes as well. So through an external system, if those vulnerabilities are patched, we'll be able to see the impact on the graph in near real time. In other scenarios, the attack path modeling may entail dealing with zero-day vulnerabilities or unknown or unpublished vulnerabilities. This is what we refer to as custom vulnerabilities or zero-day attack. So we can actually define new vulnerabilities or custom vulnerabilities and specify some parameters in terms of exploitability metrics, impact, and use the CVSS calculator, something very similar to that, in order to generate a risk score or essentially a CVSS score based on the metrics provided by the system. And that after that, we'll be able to select one or more assets from the topology graph and virtually plant that vulnerability on those assets. So this is a powerful feature because it allows us to run multiple simulations using essentially custom vulnerabilities or a combination of custom and published vulnerabilities, and run the attack path modeling scenarios on a subset of a network to see the impact. So we can think of use cases where instead of or before deploying certain applications or services to the environment, you could run a simulation and assess the impact of introducing the new services or potential exposure vectors before deploying the change across the environment. And also from a reporting perspective, all the tickets generated by the system, as well as the list of recommendations that are available, can be exported from the system and sent to SOAR platforms as well. And the system also integrates with centralized asset repos. So we're able to pull the data or push certain changes to external systems in order to keep track or changes across the asset repo, history of asset repo changes as well. So overall, using a platform such as APM can enhance the predictive and proactive capabilities of security operations teams. And it can really augment the existing controls that may be in place by doing predictive analysis on a potential vulnerability or access-based attack path that may be exposed and may be available, and then generating reports on a proactive basis. And those reports can be used to essentially eliminate the attack path before they become problematic and become incidents or facilitate incidents. One last feature related to the OT version of the application is that in addition to the attack path modeling and the recommendation generation features that we talked about, it also supports integration with passive and active scanners. So essentially the passive scanner would allow baselining and feature discovery from existing OT environments without generating any sort of traffic that could impact the environment in a negative way. And it can also highlight patterns of communication between the devices or MAC addresses of the devices that are currently on network and highlight anomalies or detect anomalies when it comes to data flows or devices that become part of a network that are not authorized, may not be authorized to communicate with the existing crown jewels. The other feature, I think we covered most of the IT and OT related functionality of APM. So there's another product that we're working on and it kind of augments APM. And so APM is proactive, preventative, and using the information that's currently available from sources such as vulnerability scanners, from SIM systems, EDR systems, IPS, IDS, and the identity sources, as well as the data that's available through firewalls, IP tables, and the other platform, which is called Hunter, will augment APM by providing UEBA functionality, doing user entity behavior analytics on data or crown jewel that's discovered by APM, and essentially providing additional context into the security issues that may be occurring across the devices. Okay, with that said, I'm happy to take questions.
Great, thank you so much. What an interesting presentation. So many different features and functions, and oh, it was just great. So I want to remind the audience that they can submit a question by typing them into the questions tab located at the top of their screen. And if we don't get to your question, someone from Neo4j will reach out to you directly, or you can send an email to webinar@neo4j.com and we'll get you pointed in the right direction. But we did get several questions that have come in while you were presenting, so we can get started with those. So here is a question. It's asking, what's the difference between APM and traditional vulnerability management platforms?
Sure, and so I would say the main difference is that the traditional vulnerability management platforms focus on vulnerability reporting and discovery. So essentially, you would get the data from one or more scanners. It could be endpoint scanner, it could be network scanners, and then using that information to generate a report. Sometimes those reports are prioritized based on vulnerability scores, but still, most of those platforms are detective in nature. So vulnerability management platforms, they report the current state. They report all the information that's available as of now, point in time. Sometimes those reports or scans are run multiple times per day, per week. But I would say that the main difference is APM is not detective in nature. It's using data and knowledge that's currently available through vulnerability sources, through threat intelligence feeds, through essentially the attack patterns, and then uses that information to infer or to predict what could happen given the current data. And it provides a certain level of prediction in terms of the attack exposure vectors, or in terms of the crown jewels that may be at risk. And then it uses the predicted data in order to generate recommendations automatically using AI techniques, which is based on recommendation engines. So in order to help mitigate the risk of those predicted paths. So I would say APM, predictive, preventative, and traditional VM systems, mostly detective in nature.
Excellent. Thank you for that answer. So here's another one that's asking, what are the data sources required to enable attack path modeling?
Sure. So essentially, the data sources, I would say, what you get in from. So one of the most important thing is to have ability, to have some data in terms of network topology. So network topology, including some asset information, like if there's an asset repo, that could be a data source for APM. We also need data from existing vulnerability scanners to feed in the CVE IDs and some of the CPE IDs and CWEs and any other vulnerability information as part of the knowledge base. We also get user information as part of the sources. So all the vulnerability data would come from existing scanner. Topology data would come from security configuration managers or firewall managers. And also user information could come from Active Directory or other IAM platforms. We also have the option to ingest SIM alerts if they're related to vulnerability exploitation use cases, or EDR alerts if they're related to privilege escalation events or related to malware artifact detection alerts, because they're relevant towards the attack path modeling processes and algorithms. So those are I would say, the main data sources for APM, but not all of these sources are mandatory. Some of them are optional, and the optional sources could really improve or enhance the graph analytics process by enriching the data. So it's like you're adding an extra layer of information, overlaying that data in order to improve the overall outcome of the platform.
Okay. All right. So, and this question is asking, what are the complementary solutions that could be aligned with APM?
So most environments will require an existing vulnerability scanner and a SIM system, essentially to provide the basic level of security monitoring, or to cover the the detective pillar. But APM and other VM solutions and other SIM systems and essentially detective solutions can really augment each other. I would say, from a proactive perspective, having a UEBA solution to help with anomaly detection for user and entity behavior, and APM to cover the vulnerability-based path modeling and access-based path modeling would really enhance the overall security strength and posture of the enterprise environment.
Great, thank you. And it looks like we have time for maybe just one more question. So if your question wasn't answered, remember, we will get back to you, or you can send an email to webinar@neo4j.com. But here is a person that's asking, who are the main end users of the platform and what are the personas?
Sure. So security analysts, essentially as part of the security operations center teams, vulnerability management teams, threat hunters, level 2, level 3 investigators, and the CISO, obviously. So I would say those are the main users, end-to-end users of the platform. But APM can also be used for audit purposes. So you can actually take a screenshot of the current state and the future state and kind of prove that applying certain recommendations had an impact or improved the overall security of the environment using a visual view. So this is something that you typically cannot get from other platforms, like the graph itself, because it's able to show you the before and after views. It's really a powerful component of APM that could be used for audit purposes as well. But I would say security operations teams, VM teams, vulnerability management teams, threat hunting teams can really benefit from a platform such as APM.
Great, thank you. I love that title, threat hunter. I want to be a threat hunter in another life. With that, I'm going to thank both of you, Ian and Ashkan. Thank you so much for your time. We really appreciate you being with us today. It was a great presentation, so thank you so much. And then for those in the audience, I just want you to know that our next session will be starting shortly, so stay tuned for that. Thank you again.
Thank you.
Thank you so much for having us.
Good day.